Please encourage me to create new videos. Please like, share and subscribe to my YouTube channel. Thanks for watching. In this video, we are going to see what is the use of volatile keyword in Java. In Java, the volatile keyword ensures that changes made to a variable are immediately visible to other threads, preventing visibility issues in concurrent or multi-threading programming. It provides visibility guarantee but does not provide guarantee from race condition or unexpected results. When a variable is declared as volatile, it ensures that all the modifications related to a variable are done directly in the main memory instead of cache maintained by the individual thread. This prevents potential visibility issues that can occur when multiple threads access the same variable concurrently, or we can say at the same time. Please note that volatile keyword cannot be applied to constants, classes or methods in Java. Volatile keyword is only applicable to variables in Java, providing visibility guarantee of variable across the multiple threads. Disadvantages of using a volatile variable are: the first disadvantage of using the volatile variable is no guarantee of race condition or unexpected results. Volatile keyword ensures visibility of variables, but if multiple threads are running concurrently or at the same time, you might end up with race condition or incorrect results depending on complexity of operation. Proper synchronization mechanism is needed for avoiding race condition or unexpected results. The second disadvantage of using the volatile variable is performance overhead. While volatile keyword ensures variable visibility, it can cause performance overhead compared to non-volatile variable. Any modification on the volatile variable require changes to the variable in the main memory rather than cache, leading to slower access time. This can cause issues when dealing with frequently accessed variables. I will explain the usage of volatile keyword with the help of very simple code example. This is just a code preview of using the volatile keyword. We are still facing the issue of race condition even after using the volatile keyword on the instance variable count, which is modified by 4 threads. I am going to run the program and you can see the output of the volatile variable count. Expected value of count is 40,000, but it will be different all the times when we run the program. High level steps for creating volatile keyword code example are: Step 1. Create the counter class. Counter class contains one class level variable, or we can say instance variable named count. Mark this count instance variable as volatile. We will be incrementing count variable with the help of increment method. And for retrieving value of count variable, we will use getCount method. Count variable will be updated by multiple threads at the same time, and it is the main candidate for race condition. This is the corresponding code of step 1. We have counter class and we are going to create the object of this counter class, and this object will be shared by 4 threads. This is the count instance variable and it is the main candidate for race condition. This instance variable will be updated by multiple threads. We have marked count instance variable as volatile. This is the increment method that will be called by multiple threads to update the value of count instance variable. In this line, we will get the name of currently running thread assigned by the JVM. In this line, we will be incrementing the value of count instance variable. By using the getCount method, we will be retrieving the current value of count instance variable. Step 2. Define the task. Create the counter task that implements the runnable interface. This counter task accepts the counter class object in its constructor. We will be incrementing the counter class variable, or we can say instance variable named count. Each thread will increment the value of count variable by 10,000 in counter task. This is the corresponding code of step 2. We have created counter task class that implements the runnable interface. This class defines the task that will be performed on the counter class object. This is the counter class reference variable. This is the constructor of counter task class that accepts counter class object. This is the definition of run method that contains logic for incrementing the counter object. We are incrementing the counter object by calling the increment method. All the 4 threads in our example will be updating the shared counter object. When we start the 4 threads, the control will go to the run method. Step 3. Starting the threads and passing the counter task as the argument. Create the 4 threads and pass the counter task as the argument to these 4 threads. This counter task further contains the counter object as an argument. All the 4 threads will be operating on the shared counter object. Wait for all the 4 threads to complete and check the final output of count instance variable. This is the main class where we are going to create the counter class object that will be shared by 4 threads. I will explain each line of code step by step. This is the counter class object that will be shared by 4 threads. We have created 4 threads and passed the counter task as an argument to these 4 threads. Each counter task contains the shared counter object. Here we are starting all the 4 threads by calling the start method on each thread. Here we are waiting for all the 4 threads to complete by using the join method. Join method causes the program to wait until thread on which it is called completes its execution before proceeding to next line of code. This block of code will catch any exception that occurs while executing the above lines of code. It will display the final count of shared counter object that contains count instance variable. The value of count instance variable is different all the times when we run the program. I will show by running the example that marking the variable as volatile does not guarantee that it will not show unexpected results. For avoiding the race condition, we need proper synchronization mechanisms. This is just a demo code of using the volatile keyword. We are still facing the issue of race condition even after using the volatile keyword on the instance variable count, which is modified by 4 threads. I am going to run the program and you can see the output of the volatile variable count. Expected value of count is 40,000, but it will be different all the times when we run the program. For better understanding, please download the source code from GitHub repository. I have provided the link in the description section of this video. Please encourage me to create new videos. Please like, share and subscribe to my YouTube channel. Thanks for watching.